Next, we are going to look at a few important types of algorithms. The first one we are going to talk about is the greedy algorithms. And a greedy algorithm is an algorithm that picks the best choice at each step or each iteration. Now, the best is in quotes here because what is the best choice? It has to be defined specifically for every problem. I cannot give a very generic definition here, but the best means at that iteration or at that step, the best choice you can find. If you are trying to minimize something, this choice will be with the minimum value. If you are trying to um, uh, go towards somewhere, maybe you will choose a direction uh, that is pointing towards that, etc. So depending on the problem, the best choice, of course, would mean a different thing. Here is a very simple example. Write an algorithm to determine the least number of coins for a particular change using 1 lira, 50 kurush, 10 kurush, 5, and 1 kurush. Okay, so the algorithm is given here, and the inputs are the amount that we would like to build in kurush, and the denominations, the coin values, C1, C2, etc., down to C sub R. So in our specific example, C1 would be 100, C2 would be 50, C3 would be 10, C4 would be 5, and C5, 1. So R would be 5 in our example, but it doesn't have to be exactly that. This algorithm is more general than that. If you have a set of unusual coin denominations, you can again use this algorithm to produce it. Now, a greedy algorithm by design is going to take the best solution possible at each iteration, and that solution will be, of course, a partial solution. So in this specific example, every iteration, I'm going to decide on the number of coins I need to use from one of the values here. Okay, so I'm going to start from the biggest one because with that I can cover as much money as I can, because I want the least number of coins. So I would like to use as many C1 coins, the largest one, as possible. So I divide x by ci, and the number, the result of this division, this integer division, is going to give me the number of coins I need from the denomination C1. Okay, for instance, let's say you have 187 kurush. You divide this by your first denomination, 100, which gives you 1. Okay, so 1 is going to be the number of 100 kurush I use, because it covers the most amount uh, by using the fewest number of coins. If I replace this one single 100 kurush with, let's say, 10 kurush, I need to use 10 of them. So the greedy algorithm here starts from the highest denominator so that I can minimize the number of coins I use. So I decide on the number of coins I'm going to use for CI, and then here I update the x value, x being the amount of change. Essentially, you are computing the remainder here, that is 87. In this example, it would be 87. And then you loop back due to this for loop. Okay, so 87 is my value, and I'm going to divide this by the next coin value, 50. That will also give me 1, and 37 will remain. Okay, so in this case, di, of course, in this iteration, d2 will be 1, and x will be updated to 37. And then you divide it by 10, which will give you 3, and x will be updated to 7. And then you will divide it by 5, which will give you 1. which is the number of C4 coins you are going to use, and then X will be updated to 2, and in the next step you divide it by 1 and you get 2. That's the number of coins you need from 1 kurush. Okay, so this is a greedy algorithm, and essentially it solves part of the problem at every iteration. But in this case, we managed to find the real optimum solution, but that is not the usual, or that is not always true. A greedy algorithm may or may not produce the best or the optimum solution. And again, this depends on how you define what is best and what is optimum. And at each step, you are trying to build or increment your solution as it looks the best. But the best direction um, within your path may not lead you to the best ever solution. So greedy algorithms, sometimes they produce the best solution and sometimes they may not. Another type of algorithm is the so-called brute force algorithms. And these are very simple. A brute force algorithm is an algorithm that solves a problem in a most straightforward manner. Now, usually this amounts to enumerating all possible solutions and then trying them one by one. That is what we mean by brute force. You don't really put any intelligence in your solution, but using brute force, you just check it one by one. Brute force here refers to the CPU power, if you like. So in many cases, this involves trying each possible solution and stopping when a suitable one is found. Okay, so linear search is an excellent example to this, or insertion sort is also.